There are a lot of videos on YouTube that show you how to convert a high-frequency start plasma torch into a pilot arc torch. Unfortunately, the vast majority of them are bunk. So you've probably seen this, where they attach a wire that goes back to the ground clamp to the torch. Seems to create a pilot arc, doesn't it? Also, you've seen videos where they take a pilot arc style torch and they attach it to a high frequency start machine. Neither of these strategies work, and they both suffer from the same problem. In order to truly convert a high frequency start torch to a pilot arc torch, you need to add some electronics, and that's exactly what I've done. So let's talk about the difference between these two styles of plasma cutter. This is a high frequency start torch. There's your electrode, there's an insulator, there's the nozzle, and that's what it looks like. So we're blowing air through here. So we call this the ground clamp, but it's not really ground, it's really positive. Our electrode is the negative side of the circuit. So in the high frequency start torch, this copper cup has to be in contact with the workpiece to start the arc. In the pilot arc style torch, we basically have an additional circuit. The negative electrode is separate from this outer sheath, and this outer sheath is connected to this pilot arc wire. So the main cutting voltage flows through this metal tube just like it does in the high frequency start torch, but we have the addition of this pilot arc wire. And that's basically what we're doing when we connect a wire here and run it back to the ground clamp or positive on the plasma cutter. The problem comes when we start actually cutting. We are bleeding off a significant amount of our cutting current through this pilot arc wire. So what we need to do is we need to add a relay here that's connected up to a circuit so that when we start getting current flow through this wire, we open this relay and we disconnect our pilot arc wire so that all our cutting current goes from the electrode into the workpiece. But the fundamental difference between a pilot arc machine and a high frequency start machine is this circuitry here that disconnects the pilot arc wire when current starts to flow through this ground clamp. So let's take a look inside my box and I will show you how I did that. Okay, in here we've got a 24 volt transformer. Over here is a rectifier bridge, and the reason I have that is because this relay over here requires 24 volts DC for its coil. Here I have a HVAC contactor, and then this portion, this is the active element. This is a ferrite ring. It's got 20 turns of number 6 welding cable around it. So this was a split ring, and I've epoxied it together so these two ends are touching, and these two ends have about a 1/8 inch gap. And then right across the tip of that gap, I've placed a magnetic reed switch. So when I activate my torch, my pilot arc wire is connected through this contactor. When I bring it close to the workpiece, the current through the ground clamp increases. That increases the magnetic force across the gap in this ferrite ring, which closes that reed switch. The closing of that reed switch activates this relay. The normally closed contacts of this relay are connected to the HVAC contactor, and it opens, disconnecting the pilot arc wire from the ground clamp. This is my current sensor. The original intent was to put the reed switch through that hole, but I found that it was much more sensitive if I put the reed switch across the gap on the top, which I've done here. So let's take a look at how this works. Put a meter set to continuity, We'll connect these on either side of our reed switch. Over here, I have 3 taillight bulbs. They draw about 8 amps all told. So I'm going to connect one side to our coil and then the other side of the coil to the battery. And as you can see, when we have 8 amps going through the coil, our reed switch closes. When we turn off the current through the coil, the reed switch opens. So what we have here is basically a current sensing relay. Okay, so here's our circuit. This is connection to the plasma cutter. This is a 6-gauge wire that goes all the way through to our ground clamp. This is a 14-gauge wire that goes through the contactor to the pilot arc. Now, when we energize this device, the contactor pulls in. The contactor is a normally open device, and in this operation we need it to be normally closed. When nothing's happening, when no current is going through here, we want to connect our pilot arc wire, so we want that to be closed. So the contactor is connected to the normally closed contacts on the DC relay. And the DC relay is connected to a little bridge rectifier and to the reed switch. Now, a reed switch is basically 2 little pieces of metal and they kind of oil can. They go click, click, and there's a magnet on one of the pieces. So as you bring a magnet close to a reed switch, it resists doing anything and then it suddenly closes. So that's what's going on here. When we get current flow through our ground clamp, we get a strong magnetic field across here. Our reed switch closes. That activates this relay, opening these contacts and releasing the contactor that connects the pilot arc. So basically, the pilot arc wire is connected until current starts flowing through here, and then this relay releases the contactor and the pilot arc wire is disconnected, allowing 100% of the cutting current to flow through this circuit. Initially, I had a simpler circuit, and I simply ran the pilot arc wire through the normally closed contacts of an automotive relay, but it didn't last very long. And in my research of pilot arc machines, I found that pilot arc relays are often considered consumable. So I wanted something that was inexpensive and robust, and there isn't anything that's as robust and as inexpensive as a domestic HVAC contactor. These are about $12 in single quantities, and they have quite heavy contacts and strong springs, and they move quite a distance in there because they're meant for switching inductive loads. So I'm hoping that this will last quite some time. And as you can see, I'm using only one side of it. So when this side goes bad, I can move over to this side. And then when this goes bad, for $12, I can replace the entire contactor. So that's my circuit. Let's see it in operation. I've got my pilot arc circuit set up here. It plugs in to the ground on the plasma cutter, and then the ground clamp plugs in here. It needs 110 volts AC for the relays, and then the pilot arc wire attaches here. Here I've got a 3/8 inch piece of mild steel, which is the maximum capacity that the manufacturer says this particular plasma cutter is good for. So I'm going to crank the current all the way up, and let's see how it cuts. As you can see, that cuts at full capacity. And that's because when our arc makes contact with the workpiece, the contactor in here opens the pilot arc wire. To be honest, I have never had any real complaints with the high frequency start function of this plasma torch. It's always started when I've needed it to, even on rusty metal, blowing bolts off of things under the hood of a car. I can see where this wire hack might be useful if you're cutting thin sheet metal that has a coat of paint on it. But pilot arc in a handheld torch it's not something I've ever felt like I've needed. However, on my CNC table, when I'm cutting complex designs, I need to be able to pierce. And that means I need to turn the arc on above the workpiece and lower it to the workpiece to make that initial hole before I start my tool path. And that's what I need the pilot arc torch for. Oh, one of the other things that I should mention is there's quite a difference in design between the two torches. And one of the things that you'll find is when you run this torch with the pilot arc wire attached and you're not in contact with the workpiece, that cutting energy is going into your tip. And if I hold this on for a long time, you'll see that flame change from blue to green. That green is copper in the tip going away. Pilot arc torch is a different design. It's a different heavier tip, and I believe it has some gas flow for cooling, airflow for cooling in addition. So this sort of handheld torch conversion, you're going to end up eating up your consumables pretty quickly, and I just don't honestly see the need for it. But on the CNC table, I definitely need to be able to pierce. I need to be able to do that effectively, and that's going to be the next video when I install this pilot arc torch on the CNC table and program it to do some cutting. This is Jake von Slatt. I'll see you next time.